Hi guys, and welcome to another video. Today we're going to be looking at trigonometry, trig theory, reductions and identities. And the question that we're going to be looking at today is from the November 2010 paper 2. And it reads as follows. Question 10. You may not use a calculator to answer this question. Simplify completely. It says sine of 90 plus theta, cos of 180 plus theta, sine of minus theta, sine of 180 minus tan of 135. Now remember that to answer this particular question, you have to have good understanding of your theory. So once again, if we look at the unit circle as covered in the previous videos, 0, 90, 180, 270 and coming back to 360, this being the first quadrant, second, third and fourth quadrant respectively. Remember, theta 180 minus theta 180 plus theta and 360 minus theta. So let's look at the first thing that we have is sine of 90 plus theta. Now in your functions and co-functions, sine of 90 plus theta will become cos of theta. So for 10.1, we'll write sine of 90 plus theta is equals to cos of theta plus cos of 180 plus theta. So 180 plus theta. So we look at our cos diagram. Remember, all ratios are positive. In the first quadrant, only sine is positive in the second quadrant. In the third quadrant, only tan, and in the fourth quadrant, only cos. So if you look at cos of 180 plus theta, remember that's the third quadrant, only tan is positive, so therefore that's going to be used to minus cos theta. And this is now a negative angle that's being tested here. Now for negative angles, remember that sine of minus theta is equal to minus sine theta. See the other ones. Let's cover the other ones one time. Cos of minus theta reduces to positive, so that'll become a positive angle, positive cos theta, and tan of minus theta equals to minus tan theta. Alright, so you just have to learn that one and then you'll know that the other ones become negative. Right, so let's look at that. So sine of minus theta is minus sine theta. Now let's look at the bottom. What do we have? Sine of 180 degrees. Okay, so for sine of 180 degrees, if you want to reduce that to a special angle, remember now that your special angles are 0 degrees, 30, 45, 60 and 90 degrees. So you'll get sine of 180 degrees plus or minus 0 degrees. Now remember that you are going to end up with sine of 0 degrees. Okay, so in the second quadrant it will be positive sine 0, in the third quadrant it will be negative sine 0, and that doesn't really make a difference because remember sine of 0 degrees is 0. Okay, so we can just simply write 0. And here minus tan of 135. Now let's reduce that. So 135 lies in the second quadrant, so we're going to use 180 minus theta to reduce 135. So once again, remember our special angle that we'll be using there is 45 degrees. So therefore that will be tan of 180 minus 45 degrees equals to minus tan 45 degrees, which will be minus 1. Right, so let's go and write that down. So this will be minus, and then we'll say tan of 180 minus 45 degrees, which is equal to, so now let's simplify. Cos of theta Don't forget a minus time, a minus is plus, so we're going to say plus cos of theta times sine of theta all over 0. Now this is going to become minus, remember now, tan of 180 minus 45. In the second quadrant, tan is negative, so that becomes minus tan of 45 degrees. And what do you have here? Minus, and you're going to say minus 1. So minus times minus is plus. So let's now simplify further. Then let's remove cos of theta as a common factor, which will leave us 1 plus sine theta all over 0. Don't forget, minus times minus is plus, so it will be 0 plus 1. So final answer will be cos theta into 1 plus sine theta. Okay, so make sure that you learn your theory, and it's all about learning the unit circle. Let's look at the second question. Now in the second question it says, prove that for any angle A, 4 sine A cos A times cos 2A sine of 15 degrees all over sine 2A into tan of 225 degrees minus 2 sine squared A is equal to root 6 minus root 2 all over 2. So let's look at the left hand side. So we're going to write that down. So 4 sine A, so 10.2 for sine A cos A, and that's going to be cos 2A sine 15 degrees, cos 2A sine of 15 degrees all over sine 2A into tan of 225 degrees minus 2 sine squared A, minus 2 sine squared A. Right, now remember, now this is the left hand side. So normally what we would do is just write down left hand side equals to. Okay, so let's just make sure we copied everything down correctly. 4 sine A cos A, done. Cos 2A sine 15 degrees, correct. Sine 2A, that's correct. And tan of 225 minus 2 sine squared A, that is correct. Now, I always double check because sometimes we can take something down incorrectly. We don't want to do that. Now, let's see, what are they testing here? 4 sine A cos A. Now, straight away when I see 4 sine A cos A, I think about double angles, because remember, 2 sine A cos A is sine 2A. So the double angle that they're testing here is sine 2A equals to 2 sine A cos A. So what do we have to do there? We have to say 2 times 2 sine A cos A. There you can see that 2 sine A cos A will become sine 2A. Now cos 2A, I'm not going to change cos 2A as yet. Now, what's the reason for that? Because remember, cos 2A has 3 expansions. Cos 2A has 3 expansions, which is cos squared A minus sine squared A, 2 cos squared A minus 1, and also 1 minus 2 sine squared A. So there's too many to choose. So we won't choose now, we'll choose later. Sine 2A. So once again, sine 2A, as you can see, this 2 sine A cos A is going to become sine 2A, so we don't have to change that, right? And into tan of 225 degrees. So let's reduce tan of 225 degrees. degrees. Which quadrant does tan of 225 degrees or 2 to 5 lie? It lies in the third quadrant. So we're going to say 180 plus. Once again, the special angle that we're going to use is 45 degrees. So this will be tan of 180 plus 45 degrees minus 2 sine squared A equals to 2 times sine 2A. Now I could have changed the bottom sine 2A to 2 sine A cos A, but I choose to change the top 2 sine A cos A to sine 2A. So this bottom sine 2A now will cancel off as follows. Here cos 2A, I'm still going to leave it as it is. Remember, there's 3 expansions for cos 2A. Only when we are certain which expansion to use, then we would expand it. Tan of 180 plus 45 will now give me tan of 180 plus 45, remember, is tan of 45 degrees. Tan of 45 degrees equals 2 minus 2 sine squared A. So therefore, I have 2 cos 2A sine of 15 degrees all over tan 45 is 1 minus 2 sine squared of A. Now if you look very carefully at the expansions that I wrote down, 1 minus 2 sine squared A is equal to cos 2A. So therefore we can now write, so that will equals to 2 cos 2A times sine of 15 degrees all over cos 2A. So cos 2A cancels with cos 2A, which will leave us with sine of 15 degrees. Now learners, we have 2 sine of 15 degrees to reduce. So let us do. So 2 sine of 15 degrees. Now remember, 15 degrees can be expressed as 45 degrees minus 30 degrees, or we can represent it as 60 degrees minus 45 degrees. Remember, our special angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So therefore, we can choose any one of the following as our special angles, because both of them would equals to 15 degrees. So 45 minus 30 or 60 minus 45 would be 15 degrees. So 2 sine of 15 degrees will equals to 2 sine, and let's choose the top one, 45 minus 30 degrees. So what are they testing here? Well, yes, it's compound angles. Remember, sine of A minus B is equal to sine A cos B minus cos A sine B. So that'll equals 2 sine of 45 degrees cos of 30 degrees minus cos 45 and sine 30 equals 2 sine of 45 equals to 1 over root 2 times cos of 30 is root 3 over 2 minus cos of 45 is 1 over root 2 and sine of 30 is 1 over 2. 2 into, so we simplify that, that'll be root 3 over 2 root 2 minus 1 over 2 root 2, which would now leave us with, we have a common denominator, 2 root 2, and we have root 3 minus 1. Cancel the 2 and the 2, left with root 3 minus 1 all over root 2. Now if I want to rationalize this denominator, remember we multiply by root 2 over 2, which equals 2. If I take that into the brackets, I'll end up with a root 6 minus root 2 all over root 2. And as you can see, that is now equal to the right hand side. Now, just a word of advice, if you stuck it in point and you forget your special angles, you can double check using your calculator. Learners, if you haven't subscribed already, make sure to subscribe to JL Maths, share this content as much as possible, like my Facebook page, Justin Lazarus Mathematics, and also check out all the videos on jlmaths.com. And I'll catch you in the next video.